Hi everybody, Mr. Rubo here. Today we are continuing on with the notes from last night's video, and we're going to look at the important features for the graph of tangent function. Our general form, you're going to notice, is very similar to the general form that we had in the for the other trig functions for sine and cosine. It is a times the trig function times b theta plus c plus d. Okay, and again, this should look very familiar. The only thing that we saw different was it was sine or cosine instead of tangent or either sine or cosine instead of tangent. And most of this all means the exact same thing. So the a value is still a vertical dilation. So it's dilating your graph by a. We just don't call it an amplitude because of the way the graph is. And it is the absolute value of a, because if it's a negative, then it does the vertical reflection. We're going to come back to the period, because you'll never guess that's the one thing that's different. Phase shift is still minus c. Maybe, there we go. So it is, again, just really another word for horizontal translation. And then the vertical translation is exactly as you expect it. It is that d value at the end going up or down by whatever the d value is. So now the period, before with sine and cosine, you would say 2 pi over the absolute value of b. For tangent, though, the normal period of tangent is just pi. So we actually do pi over b. And this right here is really the biggest difference between sines and cosines and then tangent, because of that change in the normal period. It has this change here. People forget this all the time, and that's why I'm pointing it out kind of heavily. Okay. All right, so now let's do some examples here. And yeah, so they want us in this example 4, a portion of the graph is shown above. The function f can be written as a tangent bx plus d. So you'll notice no phase shift, which is good because it does start at 0, 0. Find the values of a, b, and d. So the nice thing is, with the tangent, is actually finding the period is really nice, because all you have to do is go from vertical asymptote to vertical asymptote and see what that distance is. So I'm going to go from this one to this one. This one to this one. That's negative pi fourths and then positive pi fourths. So I just need to figure out that whole distance. Well, that would be pi halves. Okay. So we now know the period is pi halves. And just like before, where we manipulated it, where if we wanted to solve for b, we can do the normal period over the period. That also works here, right? So you could see I can manipulate it so as, b equals pi over 2, and solve this by doing multiplying by the reciprocal. Pi's cancel, and my b value is 2. Okay. So b, there we go. Now, the next thing I'm also going to look at is my vertical dilation, or sorry, vertical shift. We'll get to vertical dilation in a second, because that is a little tougher to sometimes see. So I look for where my centers are, and if you don't want to like guess where it is, it's always right in the middle of your two vertical asymptotes. So here's a center point, here's a center point, here's a center point. Well, those are all on the y-axis, which means my d is 0. There is no shift up or down from a normal tangent graph. All right, so now let's talk our a value. So our a value, what you actually have to do is go from the center to the vertical and go right in the middle. Now, in this case, it's not actually marked, but we can estimate it, and you could either go from the left or the right, and it could be any center point. So you'll notice these points right here are the points that are pretty much in the middle of the center and the vertical. And we just need to see what the y value is. Compared to the y value of the midline, well, midline's at 0, so the nice thing is we're just comparing it to 0. So this is 1 above, this is 1 below, so our a value is 1. And there you go. We can, if we wanted to, we could write this as an equation, but they don't want us to. But for the sake of just seeing it, I would write it as tangent of 2x, right? I don't need the 1 in the front, and I don't need the plus 0 at the end. All right, let's keep going. So example 5. Again, this is function h defined by this function here, and it wants the period. So the period, just like always, is still the b value, but unlike sine and cosine, instead of 2 pi over b, we're going to do pi over b. So in this case, it's pi over 2, and there you go. That's it. So again, nothing too crazy there. It's very similar to what we've been doing, but now it's just pi instead of 2 pi. All right, example 6. Let g be function, there it is, which the following gives the vertical asymptotes of the graph. Okay, so with this in mind, and actually we can kind of use this example here, our period was pi halves, right? Which if we split in half, we get pi fourths, right? And negative pi fourths. It's kind of how we figured it out. And that's where each vertical asymptote is. So as long as there's no phase shift, you can just take whatever your period is and divide it in 2, and that'll tell you where your first vertical asymptote is. If there is a phase shift, then what you're going to do is same thing, but then instead of adding it to 0, like we would if we're starting at 0, you're going to add it to whatever the phase shift is. A little harder, but still doable. Nice thing in this graph, there is no phase shift. So we're going to go ahead and figure out what the period is. So here, remember, this is really 1/3 x, right? That's another way of writing it. And there we go. So I'm going to say that my period equals pi over 1/3 multiplied by the reciprocal. So my period is 3 pi. Okay. Well, if I divide that in 2, I would get 3 pi over 2. And so if you look at all of our options, you'll notice we got pi halves, okay? We got pi 6, we got 3 pi over 2, and we got pi. And then they're adding on the repeated period. Well, even just finding this period, it tells me what my answer is, right? I actually didn't even need to do the dividing by 2, because if you look at all of these options, repeats at pi, not this one's period, right? Repeats pi thirds, not this one's period. Repeats at 3 pi k. Okay, that's good. This one's saying repeats every 2 pi. So just looking at that, I actually eliminate all the answers but C. And then if you use what I just talked about and say, oh, okay, well, divide it by 2, and that's going to tell us how far away from the y-axis we are, where the first one is, that's C, right? That gives it to us that way too. So yeah, you could also graph it if you wanted to, but this is much more of an analytical approach, right, without the need of graphing. Okay, and then our last one, oh, just kidding, not our last one. I thought it was farther down. All right, so we got our graph here shown above. Which of the following could be an expression for k? So we look, and again, I like to find the period for tangent because it's usually clear and obvious what the period is. We're going from negative pi to pi, which means my period is 2 pi. Okay. So if I'm going to use my period of 2 pi to figure out what b is, I'm going to use pi over 2 pi, which means my b value is 1/2. So right away, just looking at that, I get rid of answer choices C and D. All right, and the only difference between C and D now is the vertical shift. So now let's look at that vertical shift. I'm looking in the middle of between negative pi and pi, which is the y-axis. I see my y-axis is it right in the is at -2, which means my midpoint or my midline is at -2. So the answer has to be A. Okay. So yeah, use your answer choices to help you here. But yeah, that one hopefully fairly clear. Thing that most people probably make a mistake on is the period, because they would maybe do two, I don't know. I would think most people probably do 2 pi over 2 pi, which would be 1, but that wasn't even an answer choice, so you would know you did something wrong there. All right, example 8. Now this is the last one. All right. So here, blah, blah, function h is, there we go, tangent b of x plus c. We got to find b and c. So again, b, go vertical asymptote to vertical asymptote. Now, sometimes the vertical asymptote, if there's a shift, will be on the y-axis, which is what happens here. But hopefully you can tell from the way the shapes of these graphs are, there's a shift to it. Right? We can see that there should be a vertical asymptote. You just can't see it because it's on that y-axis. So again, the distance from here to here is pi over 2 because it's from 0 to pi over 2, which is nice. So our period is pi over 2. So the b value, I'm going to go ahead and do the little bit of math. Pi times 2 over pi. Oh, doesn't want to write. There we go. They cancel, and you get 2. So b is 2, which means I get rid of a and b. So now I just have to worry about the phase shift. Well, you have choices with the phase shift just like before. So for tangent, we usually start in the center on the y-axis, but we are no longer starting at the center. So let's find a new center point. And you could either choose this one or this one. Okay, so your C value could either be negative. So this one's C would be negative pi fourths. And this one C would be positive pi fourths, because remember it is the opposite of where it's at. And tangent starts in the center, so that's why it's one of those 2 points. So if you look at your answer choices, only one of those 2 will actually show up. Negative pi fourths, where D is negative pi halves, so we know that one's wrong. So our answer here is C. Again, you're using all your same knowledge that we've been using for sine and cosine. We're just applying it to tangent functions. And yeah, the biggest difference is that period is pi over b as opposed to 2 pi. All right, well, thanks for watching and have a good day.